Great. Okay. Well, hello everyone and good afternoon. And you're all very welcome joining us today on a webinar on sustainable engineering solutions at Trinity College Dublin. My name is Melanie Mai. I'm from the E3 project team. Some of you may have received email communications from myself or my colleagues from the E3 team. I'm one of the E3 student recruitment and admissions officers in the team. And just a quick reminder, this webinar is 1 hour in duration and it's recorded. The recording will be shared with you afterwards. And if you have any questions for us, please pop your questions in the Q&A box and we'll address them later. So let's begin our webinar. So today's webinar is about Trinity's engineering education and particularly how Trinity encourage sort of an innovation practice, either through enhancing engineering design or development of low carbon technologies or through the development of nature-based solutions with the focus to address sort of global challenges we face today. And in the next hour, we're going to cover many topics. And we're going to feature 3 programs, MSc in Mechanical Engineering, and MSc in Zero Carbon Technologies, and MSc in Engineering, and also the newly launched MSc in Climate Adaptation Engineering. Our course directors are here to give you detailed information on these courses. And also we have today a current student sharing their experience as a postgraduate student at Trinity to date. So very much looking forward to the next hour. I hope at the end of this webinar that you will have a clear understanding that the suite of sustainable engineering related programs that we offer here and the potential career and research opportunities these programs could open up for you. Okay, without further ado, I'm just going to introduce our panel today. And so I would like to introduce the first panel, Dr. Rui Teixeira, who is the course co-director for MSc in Climate Adaptation Engineering from the Department of Civil, Structural and Environmental Engineering. And also we have Dr. David O'Connor, who will be joining us shortly. And Dr. David O'Connor is the course director for MSc in Engineering and also from the Department of Civil, Structural and Environmental Engineering. And today we have Dr. John Kennedy, who is the course director for MSc in Mechanical Engineering and the MSc in Zero Carbon Technologies from the Department of Mechanical and Biomedical Engineering. And also today we have a current student, Catherine. Catherine McGrath is the current student on the MSc in Structural and Geotechnical Engineering course. Catherine is from the US. So all our panelists, you're very welcome to join us today, and thank you for being here. So before we go into talk about the programs, I just want to give you an overview on the School of Engineering. So our School of Engineering has been teaching engineering since 1841, making us one of the oldest engineering schools in the world. But today it's a modern and it's a forward-thinking and it's a research-focused school. We have 3 departments: Department of Civil, Structural, Civil and Environmental Engineering. We have the Department of Mechanical and Biomedical Engineering, and also the Department of Electronic and Electrical Engineering. And our school consistently ranked highly in the world rankings. Our professors have been very busy conducting cutting-edge research, and in the meantime, many of them run their own companies and have very strong links with industry locally and internationally. Our engineering programs are accredited by Engineers Ireland, which is to ensure that our engineering courses are meeting the highest standard and professionally recognized globally. So you see the picture here. On the top of the picture is the museum building where our Department of Mechanical Engineering and also Civil Engineering sits within. And the second picture is our robot. His name is Stevie. So robot has been, very busy and, launched the robot. Stevie is to initially to, I suppose, help with the care home, the elderly in the care home, and to provide to do help with some of the chores and also to provide sort of a social companionship. Maybe perhaps John can tell us a bit more about Stevie later. Okay, so our school currently offers 5 MSCs, MSc in engineering, MSc in mechanical engineering, MSc in biomedical engineering, and MSc in electronic information engineering, and MPhil in music and media technologies. This year, through the E3 initiative, we're launching a new program, MSc in climate adaptation engineering. And the first cohort will be starting in September 2025. So what is E3 about, and what is the relationship between E3 and the School of Engineering? So E3 is an initiative launched at Trinity over 5 years ago. It's a new type of collaboration between 3 schools: the School of Engineering, the School of Computer Science and Statistics, and the School of Natural Sciences. The core to this initiative is to address global challenges by producing new type of engineering and technology graduates, and that, to ensure that our graduates not only having the technology, sort of technical skills, but also having the green knowledge and also having a mindset that, when they're about to develop engineering solutions, and they are, sort of a deeply fostered that sort of mindset to use that balanced solution approach when developing solutions. One key component to the initiative is the E3 Martin Naughton Learning Foundry, which currently the building construction has complete and is being fitted out. And hopefully towards later this year, our E3 students will be able to use this space for their project work, for research work. So we're very much looking forward to when the building is ready. Okay, so now I'm going to hand over to our course directors, who will then take you through on the 3 courses related to sustainable engineering solutions, and give you more insights on these courses. Over to you, Rui.
Thanks, Melanie, for the introduction. I would also like to welcome everyone to this small session. So I'm going to talk a bit about this new E3 Master in Climate Adaptation Engineering, and I think that it's very important to lay out a bit what's the motivation for it. So we know that there's an increasing incidence of climate events. We've seen that this is on the rise, whether in intensity or frequency. We also have seen that disruptions due to climate, they have severe impacts in the societal systems. And we also know that it usually costs to different nations billions of units of dollars, euros, whatever cost it is to recover from these events. So I added here the United Nations because to give you a bit of context, so the last 3 years were among the 4 ever recorded for climate disruptions in terms of economic losses, which is a concern. And paraphrasing the Secretary General of the United Nations, we currently are in the battle of our lives. We also know that the promoting resilient infrastructure has significant economic benefits. The World Bank recently has shown that for each $1 that we invest in climate adaptation, we get a benefit of $4 saved in the future. And as such, it's with no surprise that the demand for specialists in climate adaptation is on the rise at present. So, maybe you can move to the next slide. Yeah. So the idea of this master is then to develop graduates that will have the technical and practical skills and will develop an holistic vision to deliver these balanced solutions for climate adaptation and climate resilience, and using, of course, kind of a triad of engineering, natural sciences, and data science, merging these dimensions of the digitalization, sustainability, and society. And the idea with this master is then to impart the core skills on climate adaptation through core modules on this topic. And we also do that, develop this empirical understanding of climate adaptation through industry-led research projects. And again, this engineering-led program, the idea is to merge the need to address the sustainable development goals with the climate action plans that are usually drafted at national level. So to give you an overview of the program, so the C3 Master in Climate Adaptation Engineering is divided into 3 phases. Each one has approximately 30 credits. So in the first, roughly between September and December, you were going to have core modules and elective modules, and you start working on this industry-led research focus. And then in between January and the second phase, you still work on your core and elective modules, and you start then with your industry-led research project, working on that. That would be then to be completed in between May and August. So what are then the unique features of this master? Then we are quite focused on this interdisciplinary approach. It's a combination of engineering, computer science, and statistics, and natural sciences as an E3 program that will provide increased opportunities to engage with students from different disciplines. And then there's a strong focus on collaboration with public and private sector. So that's through the industry-led projects. So that will give you the opportunity to work in highly industry-led research projects, because we know there's a demand for innovation and for the industries to adapt, to produce or to deliver their adaptation projects to tackle the climate change. And one of the opportunities here is to then work in those specific projects through research. Just to give a bit more detail into the program, what's in it. So in between September and December, that's the first phase. You're going to have, or you have the opportunity to have 5 modules. 4 of them are core. 1 of them is elective. So the core modules will involve introduction to climate adaptation engineering. We're talking here in issues of critical infrastructure resilience, how to address that. And then you have a global environmental change that will, it's a model that is going to discuss topics related to how is climate change taking place, what are the main drivers of it. Then we have advanced spatial analysis using GIS. So this is going to focus on geographical information systems and how to leverage those to address the climate needs. And then we have introduction to machine learning. That's where you're going to have, it's a module directed to students that are starting in the machine learning, and to give you the skills in that field. And then we have 5 elective modules. Maybe you can move. In the second phase, you then have 5 core and 1 elective. Again, in the first phase, we have an offer of 5 in this elective modules, we have an offer of 6. And in terms of core modules, we have Climate Adaptation Engineering Challenge. That's one. And Adaptation Planning for Infrastructure. These two are, again, going to be centered on the idea of adapting our critical infrastructure, water distribution systems, power distribution networks, transportation networks, and ICT networks, all the critical infrastructure to climate change. Then we have sustainable development and life cycle assessment that are also quite related to each other, where you're going to understand what are the processes to evaluate the environmental impacts of a balanced solution through the full lifetime, from the conception to the commissioning. And then we have human interactions with biodiversity that brings this dimension of what are the impacts of our decisions into the biodiversity. In terms of elective modules, as I mentioned, there are 11 on offer, probably because to keep the time, I would maybe suggest that to be checked in our website. So we have a new video over there with details on the different modules, and that would be an easy way to infer on this. And finally, we have the industry-led climate adaptation research project. Like I mentioned before, it's going to be a project where you are expected to develop close links with industry. We have been working hard to create that engagement, to bring in industries on board that they can provide or co-create a research project for a master's research project, and that would address a real world need in terms of climate adaptation. And it's just to finish, we do have more information, so it's easy to consult that in the E3 Climate Adaptation Engineering website. So I then direct most of it to the questions and to the website.
Thank you, Rui. Now, I'll hand over to David.
Good afternoon. My name is David O'Connell, and I'm the coordinator for the MSc in Engineering. The MSc in Engineering is divided into a number of areas, looking at environmental engineering, structural and geotechnical engineering, sustainable energy, transport policy and planning, all under the umbrella really of engineering, and particularly civil engineering. So the MSc in Environmental Engineering very much focuses on water, air, and soil pollution. We teach and work with students relating to solutions to protect the environment and society, and also examining and have projects related to climate change, sustainability, and renewable energy. And a lot of our core modules look at these also. So the MSc in Structural and Geotechnical Engineering then look at the sustainability of buildings and structural materials. Also in terms of earthquakes, bridge design, soil structure interactions, advanced modeling and analysis of structures, just to give a taste of some of the topics covered. The MSc in Transport Engineering, Policy and Planning then look at transportation engineering, policy planning design, and also very much look at the modeling and analysis of traffic and transportation in general. The MSc in Sustainable Engineering then, which is quite popular, looks at efficiency techniques, sustainable energy technologies and energy management systems and strategies, very much focused on climate change, sustainability and renewable energy. So we have a T-shaped teaching to provide a breadth of complementary skills, provide a depth of specialist knowledge and skills, enhance the students' employability skills, and enhance the students' self-development skills. There are a total of 28 modules, so there's a significant choice there. And I think this is one of the major attractions of our MSc. We have 4 mandatory modules, M1, M3, M4, and M5. 5 environmental engineering modules, 8 structural geotechnical engineering modules, 4 transportation modules, and 4 sustainable energy modules. And then we have 3 common modules. So the students will complete 4 mandatory modules. So these are M1, M3, M4, and M5. Complete 8 other modules, of which 4 modules have to be from their selected discipline. So if you want to do environmental engineering, 4 of those have to be from that discipline, and submit a research dissertation during the summer, we work in that full-time, generally from May to August. And at the end of the course, you would have completed then 90 credits in total for your MSc. In terms of career prospects, the course is well recognized worldwide. The course is accredited by Engineers Ireland, recognized by EURACE under the Bologna Declaration. It's internationally recognized by the Washington Accord signature countries, including Australia, Canada, China, India, South Africa, the UK, and the USA. And it also has a high reputation. It's one of the oldest civil engineering MScs in the country. There are scholars and awardees with Naughton Fellows and Irish Aid Fellows. We also have part-time students from industry. These usually account for about 10% of the class. And there's a great international component. So international students from dozens of countries, about 80% of the class are composed of these students. There's a high level of employability. Many of our students get jobs or offered jobs before they even finish the MSc. So relevant industries, national, international companies such as CISC Group, Mercury Engineering, Accenture, ESB International, PwC, Jacobs Engineering Group, the Royal BAM Group, etc. Local county councils domestically within the country, also including Dublin City Council, Cork County Council, etc. And also further education with TCD in terms of PhDs, Cambridge, University College London, Imperial College London, if you want to go down the academic route. And so here's just a breakdown of percent response from recent graduates. So employed is almost 80%. Those who've gone into further study or training, 7.7, seeking employment, 12, traveling, 2.6%, and unavailable for employment, 0. So it's you can see there the employed is pretty high. Minimum requirements, at least a 2-1 honours degree from an Irish university or an equivalent international university in relevant areas. We look for English language proficiency and also 2 satisfactory academic reference letters from your institutions where you studied. Specific requirements, at least a B in core modules of relevant stream. So that's a requirement. In terms of environmental engineering, we'd look for environmental engineering, environmental science, any background in water, wastewater, waste, hydrology, air quality, environmental impact assessment. All of this is taken into account when looking at applications. In terms of structural and geotechnical, we'd look at structural engineering background, geotechnical modules maybe attended by the students, steel, structural, concrete, structural analysis, and soil mechanics. Thank you for your attention. If you have any questions, I can deal with it afterwards.
Thank you, David. Now, over to you, John.
Okay, so thank you very much. So I'm John Kennedy. I'm an assistant professor here in mechanical engineering in the topic of noise and vibration control. So Melanie, if you can click onto the first slide there. Keep going. The MSc in Mechanical Engineering and the MSc in Zero Carbon Technologies are both hosted within the Mechanical Engineering department, and they both have a similar structure. So it's a very flexible structure. We can do 1 year full-time, 2 years part-time, 3 years part-time. We also offer a postgraduate diploma and a postgraduate certificate, and you can upgrade from these qualifications over time, beginning with a PG cert, moving on to a diploma and an MSc. So it's a very flexible structure for both programs that allows different, I suppose, time commitments depending upon what your stage is at in your career. So thanks, Melanie. If you got the next one. So the structure for the 90 credits for the courses is we have a significant research component in the dissertation, and we have 60 credits in taught modules. So there's a combination of compulsory and optional modules on both programs. And the main difference between the two MSCs is that the MSc in Zero Carbon Technologies has additional compulsory modules in the thematic area of zero carbon technologies. The MSc in Mechanical Engineering is very flexible and has a wide range of module choices. So I'm going to speak a bit about that first, and then I'll move on to the zero carbon technologies. So in the MSc in Mechanical Engineering, of the 60 credits taught modules, 15 of these are compulsory related to research methods and the research component of the MSc, and 45 are taken from a wide range of 23 different optional modules. So really this is an extremely flexible program, and it's really up to the students to decide what type of content you need for the career that you want. So we have a wide range of specialties and expertise in the department, from manufacturing, biomedical engineering, turbo machinery, noise and vibration, thermodynamics, and so forth. And all of these can be related to the question of sustainability. So within the manufacturing environment, you could be talking about, circular economy and minimizing waste in manufacturing processes. Turbo machinery, you could be talking about new methods of power generation. Thermodynamics, you could be looking at advanced cooling techniques for data centers to reduce power consumption. So really all aspects of the program can have a strong sustainability slant to them. Okay. If we move on then to the zero carbon technologies, the difference here is that we have some compulsory modules which are also available to the main mechanical stream, and these include low carbon transport and low carbon power, which are two significant modules that you undertake as part of this program. And then you have to take at least one module from this list of wave energy, so wind energy, wave and hydro energy, solar energy conversion applications, energy policy and energy storage. And then you have a remaining 20 ECTS, which is flexible, and the full list of modules from the Mechanical Engineering MSc is also available to this zero carbon strand. So you can add a little bit of a unique flavor to this if you want to have a module in deep learning, or if you want to look at something additional like noise and vibration control or whatever it might be for non-CO2 pollutants or things like this. You can add an extra flavor to your MSc with that. So moving on from there, what I would say is the strong distinguishing aspect of both of these MSCs is that they're very research focused. We really put the question of research at the core of both of these programs. You're going to be working with professors who are world-leading experts in their fields, and you're going to be integrated into their research teams with their PhD students, their postdocs. You're going to be part of a small group of high-performing and high-achieving students, and we actually, within our grading schemes, reward students who achieve significant real-world output in terms of international conference presentations, top-tier scientific journal publications, and I have some photographs here of recent graduates who've been presenting at conferences just last October. So we really do expect that we will give you a real research question in the area that you're interested in, zero carbon technologies or another aspect of mechanical engineering. We'll support you to make a real-world contribution from that work, and we'll help you get that information out there into the real world by presenting at conferences and publishing in journals. So moving on from there, and maybe just a little bit more about this on the next slide. Thanks, Melanie. Is basically, we don't offer an industrial placement as part of either of these MSCs. However, all of the professors have very strong links with industry. Some of them have their own companies, and the research projects that you'd be involved in as part of the MSc are directly linked to these national and international research projects that the professors have ongoing, and with their industry-funded research that they have. So really, as part of making you have a real world impact in terms of a conference or a scientific journal, we're also getting you to have networking opportunities with the industries related to that area. And having an international conference presentation is a very nice thing to be able to say in an interview or something like this, as well as the outcome from the MSc. So moving on from there, if you want to see who we are, so if you're thinking to yourself, I want to come and do an MSc here, and I'm going to engage with some research, I think it's important that you investigate who we are. And if you look at our profiles on the manufacturing engineering website, you can also look at the research groups that are on there. You should look us up on Google Scholar. You should look us up on ResearchGate and on these platforms. See the papers that we're publishing, see the international projects that we're engaged in, and ask yourself, is there somebody here on the MSc program that you would like to work with, that you would like to mentor you through your first contribution into making a real world impact in the question of sustainability in the mechanical engineering environment? So do look us up and see what we're doing, and all of us are very research active. So moving on from there, talk a little bit about the admission requirements. We're looking for an honours degree in mechanical engineering or similar. So particularly on the zero carbon technology strand, that is open to a wider pool of people than just a core mechanical engineering graduate. If you're coming in from an environmental engineering or a sustainability background, we want to hear from you. However, what I would say is both of these MSCs are technology focused. We want to develop new technologies, technical solutions to these problems. So there is a lot of core engineering involved in terms of fluid mechanics, thermodynamics, power cycles. This is knowledge that will be, covered in the MSc, and there's a certain amount of background expertise required to get into that space. And we will be looking at, work experience that you have, training courses that you've undertaken. Your personal statement is very important here in explaining to us why you think that this is the correct MSc for you, and if you have, a sort of an excellent personal statement justifying your career trajectory and why you think this MSc will helpful, we will absolutely take that on board. So next up from there, I think we're almost at the end. So the type of applicants that we're really looking for here, I mean, if you see yourself as a high achiever, a person who wants to make a real world contribution from your work. If you're interested in research and development, this is excellent MSc for this type of area. Working in a high-tech industry, looking at developing next-generation power systems, propulsion technologies, electrification of transport, all of these very, very necessary technologies that we need for sustainability. This is an excellent MSc for you. And also, because we're extremely research-focused, we will be looking for outputs from conferences, from journals. If you're continuing on to a PhD, if you are applying for a PhD and you have a track record of publication at international conferences or scientific journals, that's extremely strong application for any PhD program. So I think that's it for the MSc Mechanical Engineering. So we might have some questions for this at the Q&A at the end.
Thank you very much, John. And thank you to all the course directors for providing us more detailed information on your courses. Just before we go into the next part of our webinar, to addressing some of the questions, I would like to just mention very briefly on admissions and scholarship opportunities. So applications are open for September 2025 intake. The application process is relatively simple and straightforward. If you visit the site link there, and you'll be able to submit and follow the steps and submit an online application along with the documents required, including your complete academic transcripts and your degree qualification, if available, and proof of English language, and 2 reference letter can be both academic reference, or it can be 1 academic reference and 1 professional reference, and a copy of your passport, CV, and also to include a personal statement. Just to flag that admissions are processed and managed on a rolling basis. So for courses, our engineering courses are generally very popular. So once, the course is full, suitable candidates may be placed on the waiting list. Just want to flag that with you. We also offer, with me, scholarships. So because we get many questions on the scholarship opportunities, we do offer a number of scholarships to our offer holders. So if you do hold a course offer from our engineering programs, that you are encouraged to apply for the E3 postgraduate scholarships, whether you're EU, European fee status, or non-EU fee status offer holder. We offer scholarship value between 2,000 to 5,000 euro as a partial fee deduction. Also, just to flag, this year, we are introducing some dedicated E3 scholarship for offer holders that are joining the MSc in Climate Adaptation Engineering course. Also, our Trinity Global Office, and they offer Global Excellence Scholarships for both EU and non-EU candidates. Again, the details can be found through the links there. So we also understand that, before you decide to choose to study with us, and, you'd like to hear from a student's perspective. So you can chat with our postgraduate current students, and the link there will give you the opportunity to connect with our current students, and you can ask about, their experience, about life in Trinity in Dublin and in Ireland. Okay, so this is the end of the slides, and these are our contact details. If you have any question, you're more than welcome to email us or follow us on our social media channels through LinkedIn or Twitter or X. You're more than welcome to get in touch. So now I'm going to stop sharing and start our discussion session. And so we have, again, thank you to all the panelists being here today and to share your insights. And so early on, you have told us, about your program, some of the unique features. Just very, very quickly and briefly, can you give me a summary and very quickly, why prospective students should consider your program? Can I come to you, Rui, first?
So I think that resides a lot on the motivation of the program. So it's so for those, I don't know if any of these are from Ireland, but you would be familiarized with what happened this weekend. So I know there's a very significant challenge. It's there's a global message on that we need to address climate impacts. They are devastating, usually when they take place, and I think that would be there's a strong demand for this type of knowledge in the future, aligned with some of the unique features that we offer, like the possibility of working very closely with in real world place-based projects, and again these interdisciplinary features that we have in our master, aligned with the possibility to be in the E3 environment. I would say these are very critical or key features to what is of interest in this program.
Great, interdisciplinary. Now, David, can I come over to you and tell us, why should students consider the MSc in engineering courses?
Well, certainly, our engineering MSCs are very interdisciplinary. Also, they address climate change issues. So if that's something that you want to examine, also students are highly employable. As I said, the majority of them get jobs before they even leave the college. You get a core education in some very solid foundations in the various aspects, whether it be sustainable energy, environmental engineering, transport, or structures, and again, high employability, I would say. And also get to take part in frontline research, really. We have a significant research active colleagues and staff in our MSc, and they get to work on national, international level research projects. We're known for it. So that's
wonderful, wonderful. So very high track record on employment and research. And John, I know you've already shared many of your unique features on the program. Just to again remind us, why should students consider your program?
So I think for both the MSc Mechanical Engineering and the MSc Zero Carbon Technologies, as I sort of mentioned, they're technology focused. We need new technologies. If you look at the climate action plans and the roadmaps 2050, if we want to reduce carbon, we need to change the technologies that we're using. We need new technologies in automotive. We need new technologies in aviation. We need new technologies in power generation. We need new battery technologies. These are all within the, I suppose, the expertise of mechanical engineering. And this MSc, or these two MSc programs, will provide you with the technical understanding necessary to be the engineer that invents these new technologies that we need. And you'll get to work with the professors who are leading the charge in generating these new technologies as part of their research programs at Trinity.
Great. Okay. Now I'm going to come to you, Catherine. So Catherine, can you tell us what have you made you to decide to come to Ireland, to Trinity and to do the MSc in structural and geotechnical engineering course?
Yeah, also I had done my undergrad in the US, and I really decided that I wanted to come to Ireland because I wanted a little bit of a different perspective. And I was especially interested in the research, the potential for research in existing structures. And I've sort of gotten the chance to do a little bit of work on that in my research project. Um, so yeah, I think it was the opportunity to study different things and different structures and different methods of construction and design and everything than where I had studied previously in the US. And I think also the diversity of the program really attracted me. So I do have family here, but as an international student coming from a different country, the fact that there are so many international students in the program, um, we've all bonded pretty well. And I mean, the existing students, like the fifth year students that have come through the program at Trinity, are all very welcoming and very friendly. But it's really this environment of everyone comes from different backgrounds and different experiences. There are some more experienced students who did work for a while and then came back to school. There are people who are coming out of their undergrad. There are people that don't even have an engineering background that have come into the program. So it's just since coming here, it's that opportunity of talking to everybody and getting to sort of hear all these different perspectives, and get to know all of these different people. That's made for, just an extra bonus as like a well-rounded education, I think.
Great. I'm really glad to hear that. So what sort of a typical class size, or it depends from module to module?
It definitely depends. I think some modules are certainly more popular than others. So there were some that I think it's a little bit more balanced this semester, but last semester I was in one module that had 8 students and others that had 30 to 40. So I think one thing that's really great is that the professors, no matter the size of the module, their doors are open. You can walk up to them after class and ask them questions. They're all very, welcoming and eager to explain things to you and take the time to help and make sure you really understand things. Very approachable, which is really nice. So to be honest, even though the class sizes kind of vary greatly in some cases, it's not really that noticeable.
Really glad to hear that. So tell me, what is your favorite or that the module that you enjoyed most to date?
Um, I think the one that I've enjoyed most, I had a module on just a theory of structures, and that was really, I mean it's theories in the name, but it was a very theoretical module, but it was taught really well by these two professors in the structural engineering department. And I'd never had lectures that were so clear before. They would explain things and write out derivations and go step by step and pause to make sure people were following along. And I really felt like I got a good grasp of the material. And, it was certainly difficult and there was a lot of self-study that I had to do. But by the end of last semester, when I was coming around to take the exam, I really felt like I had learned a lot and I was kind of enjoying myself. So I think there's definitely no module is easy. There's a lot of work that came with all of them, but um, I've really enjoyed learning and being in the classes so far. So
Fantastic. I'm really glad to hear that. So when you talk about, how the modules delivered, I'm going to go back to the course director in terms of our teaching generally, the delivery format. John, could you just, tell us, generally speaking, are all the modules delivered face to face, or some of them maybe, through the online delivery, or even for those modules that are delivered face to face, is there an option, or will they be recorded?
Yeah, so this varies a little bit between modules. And the MSc in Mechanical Engineering has a very wide range of modules to choose from. In my own personal module, I still live stream my lectures, I record my lectures, and I share that content available to the students so they can learn asynchronously in my module. But in a different module, which is maybe very much design focused, it might be absolutely necessary to be present physically in the room with your design team, working on the problem, and it's not really possible to deliver that structure in a blended or online environment. So what I would say is that we would recommend that all students are attending face to face because that's what's getting the best experience in terms of accessing the lecturers, the teaching assistants, and getting the most from the program. We do have students who are working on the programs part time and who have managed to arrange a flexible program of study. But I would say my recommendation is to be in the room, be present there, interacting with the other students, interacting with the lecturer in a face-to-face mode of delivery. But there is some flexibility available for people who wish to work part-time as we're doing this.
Okay. So now I'm going to ask you move on to sort of a research opportunities. Perhaps the course directors, you could give me some examples on the type of research topics or project that your MS students potentially would have the opportunity to work on. Maybe David first.
You repeat that question there? I just missed that there.
Sorry, yeah, David, just on the, would you be able to give me some examples on the research topics that your students
Okay.
will have the opportunity to work on?
Yeah, so many of the students get to work on various topics related to the circular economy, for example. So repurposing waste products into valuable, useful products in terms of water treatment. That's just one example. Other students get to work on modeling projects, whether it be traffic flow, um, or coming up with some new machine learning techniques and technologies to help traffic flow, for example. I know they do that. Also, in terms of groundwater modeling, some machine learning and modeling around that. There's a whole multitude of different topics and different projects, whether it be funded nationally by some of our national funders here in Ireland, or whether it be EU based or even international. The students get a chance to carry out some of this research in collaboration with the researchers, the supervisors, the PIs, but also PhD students and MScs. So they actually have that guidance and that help as they're carrying out some of the more detailed research.
Great. Okay. Rui, can I come to you? I know that your first cohort will be starting this September, but could you give us some idea that students joining the climate adaptation engineering courses, that because it's interdisciplinary in terms of their research and potential, and also that your research project, and has that unique feature, industry-led sort of a unique feature. Can you just maybe give us a bit more, information on the type of topics in terms of supervisor? Can they be supervised by professors outside of the School of Engineering, for example?
Yes, absolutely. So one of the characteristics of this master is that it's open to a broader range of applicants from STEM and related backgrounds. So we want to promote this fostering of different know-how from different fields. That's something that we consider. So every research project should have an industry and academic supervisor that will work together, and that can be from different disciplines also. And well, just if I would detail some examples, I can speak of my own experience with that, or some of the collaborations that we have ongoing and what we want to promote further. That could involve, for instance, understanding the risk in the future for let's say for the Dublin area in terms of climate effects. That could involve flexible planning of adaptation measures that could to go through criticality or all to address the vulnerabilities in the systems. how to design nature-based solutions where we could bring then that dimension of biology, ecosystems into the kind of solutions, and the research is going to be then focused on these areas that again are related to climate adaptation, and to provide solutions that will have this interdisciplinary character too.
Great, great. I see there are a number of questions in the Q&A. Perhaps we could go through some of the questions there. And since I have you there, Rui, so I have one question from Tusha. I'm completing my master's biotechnology from India. I'm passionate about sustainability and bioenergy. So Tusha wants to know so the current research interest resonates around climate change solutions, and previously has worked on project on the second gen biofuel production, and currently working on the nanotechnology applications in agriculture. So with someone with such profile, would they be considered suitable candidates for the climate adaptation engineering course?
Yes, absolutely. So, by the way, very interesting. It sounds fascinating. Yeah, this is the kind of knowledge that we want to promote. So it sounds like one of the reasons why in our in the structure of the master we have some time in the first phase to discuss the project is exactly to seek what opportunities there could be to promote new ideas, innovative ideas, how to pair that with industry needs and the collaborations we have. And I would say that, yes, I think that is in the scope of of course, we would discuss that further, but that is in the scope of the project.
Again, the entry requirements for climate adaptation engineering. Do students have to be coming from an engineering background, or you are open to students from a broader sort of a STEM background?
Yeah, so that's one of like I mentioned before, we are open to a broad range, and that's because that would be necessary for to deliver these balanced solutions where collaboration is at the core, and also the modules are structured to account for that. Let's say if we have group work, to have this pairing of knowledge, and then we also have modules directed to impart or to deliver the new and core knowledge in this topic.
Great. Okay. And so we have questions around so for maybe this is a question for you, John. So MSc in mechanical engineering, is there opportunity to have joint research with Irish and Indonesian institution?
Okay, it's a good question. So in terms of international collaborations during an MSc research project, there may be an existing collaboration with the supervisor's research network. If the student has, in this case, I think the student wants to bring in a collaboration to the project, we can facilitate that. But from our side, it's a higher risk proposition, because we're not sure if you're relying on this collaboration to provide you data, or to allow you access to a testing environment, or to bring in information into your MSc. You would have to take responsibility as a student to make sure that that flow of information comes into your MSc project. So I think from our perspective, it's safer for us to allow students to access our existing collaborations where we have a long established sort of trust with the partner institutions and with the industries that we work with. But we are, of course, open to fostering new collaborations and bringing in new interactions. And if a student is coming in with a strong collaboration to industry or to an academic institution, we can look at structuring around a research project to see if we can help develop and foster that collaboration. But I would say from our perspective, it's a little bit higher risk. So the student would have to convince us that this was a safe proposition.
Great. Okay. So on the research, actually, I want to go to you, Catherine, in terms of your, current experience with your dissertation process. So far, could you tell us a little bit, your journey so far?
Yeah, so I would say my journey is a little bit, I don't know, unorthodox in that I read through all of the professors' bios and was really looking for who had a specialty in the vein of research that I was interested in pursuing. So I am not sure it works this way for all of the programs, but for the MSc in engineering, they compile a list of all the potential projects you could do and send it out. But they also say that you're able to pursue your own research if you're so interested. So um, before the program even started or I came to Ireland, I just read through the website and found the faculty that I wanted to work with. So I reached out at the start of the year um, to Alan O'Connor, said, "This is what I'm interested in doing. Would you have any capacity to take me on? He said, "Yes, let's meet up." So we sort of approached it from that perspective of having a conversation about what I was interested in doing and how it aligned with the research experience that he has and how he could support me in suggestions that he has. Um, so it's been very positive so far in that regard. I think that they're quite good about ensuring that student and supervisor relations go fairly well. All the other students I know have had pretty good experiences with their supervisors. And I think it's interesting to see how everyone progresses a little bit differently depending on what sort of research you're doing. So I know at least in the engineering, there's a lot of differences in that some people will do lab work, some people will do analysis work. So mine's more on the analysis side. Um, so I think that everyone sort of goes at their own pace and develop, at least at this stage, it sort of develops as it will. There are a couple of assignments or sort of milestones that are set out for us. So we just turned in our ethics assignment, I think was due today actually. And then we have our literature review, which is due in a couple of weeks. So everyone's sort of working on that on the same timeline. Um, and it's certainly a little bit tricky to balance working on the dissertation with getting all of your module coursework done, and sort of prioritizing that during the semesters. But at the same time, not leaving the dissertation behind, making sure to take time to read through research articles or existing literature throughout the day and sort of make some headway on it. But I think also keeping in the back of our minds, all of us, that the summer months like May to August is really the time that we have to work on it. So I would say it's going well so far, but we'll see. There's still a long way to go.
Great. And also, Catherine, we had a conversation 2 days ago and you have told me congratulations on accepting a job offer. So that's
Thank you.
fantastic. So could you tell us a little bit more how did you get to this point and your experience and perhaps, what sort of a career support that you feel that has been offered by the college, by the school, and in terms of this, finding this job opportunity, just share with us your journey to this point.
Yeah, for sure. So I guess I sort of came in with the idea that I wanted to look for a job. But I think my experience at the start is probably similar to most international students in that you are sort of unfamiliar with everything. So just kind of getting acclimated, but especially unfamiliar with the industry. So the first thing I would say that really helped is there is a series of career fairs at the start of the year, that are sort of more geared towards graduate programs. So it's a little bit more of the larger companies. But going to these definitely helped me to sort of familiarize myself with both the interview sort of talking um, culture here, which is a little bit different than the US. It's a little bit, I mean, it's still formal, but a little bit less formal. Um, but just sort of getting comfortable with that. And then I would say the other resource that I really, really heavily utilized so far is the Career Center. They offer free sort of meetings for students with their counselors. So I've gone a couple of times and met with Marielle from the Career Center, who has been absolutely fabulous. Every time I come to her and I have my updates and my ideas for things that I think I might want to do, but I'm not sure. and might have seemed a little neurotic at times, but she's been great about sort of parsing out what it is that my interests are and my development so far, and it's helping me set goals. So I would say that's been really great. And then the third thing that sort of stemmed out of that advice that I got from her at the Career Center is what actually landed me this job, which is come January or the new year, there are fewer career fairs or opportunities to go and meet a whole bunch of companies. But what I did was just research companies online and find, structural engineering in the Dublin area to sort of figure out what it is exactly I'm looking for and who has stuff, who might still be hiring, who says on their website, reach out to this email. So I just compiled my CV, wrote a little email, attached a cover letter, and sent it out to, I think, maybe 10 companies in one day. And this one was actually the first one to respond. But I got a couple of interviews out of that process. So I think that just a little bit at the beginning, definitely not being afraid to use the college's resources and try to familiarize yourself with the lay of the land. But not panicking if that doesn't pan out, because there are certainly opportunities throughout the year, even I'm sure right up until graduation, to reach out to people and make connections. And yeah, just put yourself out there, because if you don't try, you'll never know.
Great. Well, thank you so much for sharing. I know, David, you're on a tight schedule. Can I just ask one final question, David? Because often students are interested in like sustainable energy, but there are two programs. There is sustainable energy engineering, and then there's also energy science. Just can you tell us a little bit more the focus on the sustainable energy engineering course, how that differentiate from this course and energy science course?
Sustainable energy engineering often looks at things at a higher level in terms of management and putting technologies in place. Also, it does involve as well some technology development. I mean, we cover solar, wave, and wind. So, there's quite a breadth of research there also, with some of our very experienced professors as well in these areas. So the students do get a chance to work in those areas. But I'd say more the engineering is more of a management, and actually how would it work? How can we get these systems? How can we see how they can work better for us for a renewable future, etc. And yeah, for the science, renewable science, or a sustainable science would be more, sustainable energy science would be more about the technologies and the nuts and bolts of it, really.
Right. Thank you, David. We have a question on mechanical engineering, John. So, Adria is asking that well, he has applied for the master's in zero carbon. He has 20 years of industrial experience in oil and gas, and would they be considered a suitable a candidate, or for the MSc in research?
So I think maybe I could just say that generally we're very welcoming, and we want to hear from people who have considerable industrial experience. We want the technologies that are coming, being developed, and which we're exploring in our modules and in our projects, to make it out into the real world. And a person who's coming in from industry has an extremely valuable perspective on how to make something function out in the real world, in a real engineering environment, practically in a real industrial setting where there are economic influences and so forth. So we'd be very welcoming to anybody who's coming in with industrial experience. And I think one of the things I'd recommend is, in your personal statement, explaining the journey that you've taken from your original qualification through your industry career process, and why it is that you want to study this particular MSc, and what you think you will gain from undertaking that. And we will carefully read those, and absolutely during the interview process we'll have an opportunity to discuss these kind of things, and give a person a chance to tell us about their experiences working in industry.
Conscious of time, and just one final question I want to ask all of you is the program that once completing the program, what type of jobs or career or companies that typically graduates from your program have gone on to, or are potentially could go to? Maybe Rui, can I start with you?
Absolutely. So at the moment, we don't have graduates yet, but hopefully in the future. But I so the that can come through private companies that would be parallel streams to uh, civil engineering, environmental science, or planning. Could be the type of topics. We have also some, for instance, in the engagement, we've seen some interest from public stakeholders or stakeholders of infrastructure systems. And uh, that would be probably so just building a bit on the, what was mentioned before. We do know there's a demand for it, so we talk with different actors in the sphere of adaptation that go from the city councils here to the industry, or to the companies that are delivering that, to the academics. And so we do see that demand there. Sometimes I'm talking with in a fair, in an exhibition, with some companies. We need to 12 graduates with this skill. Well, we don't have that. So we know that the demand is there. So, and I believe that's going to go in that direction. Yeah.
Yeah. And how about for David, just would you be able to?
Yeah, I mean, we have a vast history really in employment for students across the world, and they're all over the place. Working with environmental engineering consultancies, they work oil and gas companies, they work for renewable energy companies. Also, Vistas is one, for example, with wind turbines and all that in Europe. One of the biggest players in Europe, I'd say. Also, international structural engineering companies, not just Irish, but international ones. A lot of our students obviously are international, so they go back to their own countries. They might work in Ireland for a year or two, and then they might transfer home, or they might stay. But yeah, there's absolutely very, very high demand for our graduates, I would say, and yeah, no problem getting employment for sure.
Absolutely great. John, can I come to you on this, please?
Yeah, I'd sort of echo what David said there. So, I mean, maybe the directions our graduates might go into, they might go into automotive or aerospace applications for companies that are looking at new technologies in those spaces. We might find them in large multinational consultancy firms. And really, I suppose it's very broad in scope. And I think one of the strengths of the mechanical engineering MSc in particular is that you can really have a different flavor. You can have somebody who comes in and does like power generation, turbo machinery, and ends up in a power generation sort of role. You can have somebody who comes in and looks at thermodynamics, fluid mechanics, and goes off into data centers and energy systems there. And you can have very, very different career paths. So it's very, I think what I would say is, if you come in with a clear vision for what your career wants to be, and you correctly structure your modules, and you choose a supervisor with experience in that area, you exit the program in very strong sort of situation for continuing advancement of career in that area.
That's very promising. And yeah, so for the Irish economy, or for many economies that these are the skills that are very critical to the economy and to the development. So I'm just conscious of the time. I know we have a number of questions we haven't addressed, and they're relating to admissions, which I'm going to contact you individually after this webinar. So as we're approaching to the end of the webinar, I just want to say thank you to Catherine. Catherine, you have taken, time out of your busy study schedule to support and to be with us today. So thank you very much. And thank you to all the course directors providing so much really wonderful insights and information on your courses. And I hope the audience today would have a much better understanding of the courses that we offer, and the benefit that potentially you could get by joining these programs. So the recording will be shared with you afterwards, and we'll get back to you with the queries that we haven't addressed today. And again, thank you very much and have a good day.
Thank you, everyone.